Hello guys, and welcome back to this tutorial number 5 of our series Let's Create a Video Game. So we're gonna learn today about prefabs and loops. Let's start from prefabs. What are prefabs? So basically the idea is to create templates, so blueprints, from which you can generate instances so that you can place them in the scene, and all of them will be referencing the prefab, and changes on the prefab will reflect to all instances in one shot. So I'm going to modify the logic we had last time by creating a new empty actor here, create empty, which I call elevators manager. Elevators manager will contain all of our elevators. So let me reset this transform, right click, reset, so that it's centered at 0, 0, 0. And I'm gonna take my cube, which was my elevator last time, and I'm gonna bring it inside to elevators manager as a first child. I'm gonna rename these to be elevator 1. This is the first elevator in the list. And if you scroll down, remember we had our elevator script on this object, which will now change, okay? So let's see the design first. We'll learn a little bit about prefabs, and then we'll get to the coding part. How can I make a prefab? First of all, let me go into the assets, and I'm gonna create a new folder, right click, create folder, and I'm calling it prefabs. Now it doesn't need to be exactly that name, and double click on that. And as soon as you drag and drop any object onto this prefab folder, this becomes now a prefab. Two things happen here. First of all, you notice that the object in the scene became color blue, which means it's a prefab. And this object here is now a prefab that you can modify. So for example, let me just show you how we can modify a prefab. So I'm gonna double click on a prefab. So this is the prefab view. And of course, you can make changes on these objects just like if they were in the scene. But as soon as you click back here, this will bring you back to the scene by saving all of the changes that you made on the prefab. For example, if I had an object, if I had a component, a script on this prefab, you save this, and back to the scene, all of the instances referencing that prefab will have the change applied, unless they override specifically, and we'll see the example later. Now what I'm gonna show you is how to modify a prefab directly from the scene. For example, let's assume I want to modify this elevator prefab. I'm gonna make some change so that it becomes an actual elevator. So I'm gonna create a ground and a couple of doors. I'm gonna change this scale Y to be 0.1 so that it looks more or less like a ground. And what I'm gonna do, I'm gonna add a couple of children doors to this elevator. So I'm gonna right click on this, create 3D object cube, which I call door R. As you see, there is a plus, green plus here, which means I'm going to add things to a prefab instance. So right now the prefab instance is overriding that prefab by adding an object. So if I want this object to become part of a prefab, I need to select the prefab, go into here, overrides, and say apply all. The door itself becomes part of the prefab. So what I'm gonna do, I'm gonna modify this door directly on the prefab. So let me double click on that again. And here, if I open it up, I see the door, which is a cube. I don't see that, but let me make some change and actually making it become an actual door. Here we go. This is our door right. And now I'm going to duplicate this object so that we have a door left. Here we go. I have a door left. And what we will do in the code will be basically making these two doors sliding and opening like that. And once the elevator reaches a platform level, we will open and close the door automatically. So let me save this prefab. I'm gonna click here. Otherwise, you can also discard changes if you don't want to save them. So let me save, go back, and you see that the change that I applied to the elevator get applied also on the instance. Now, what happens if I have multiple instances on the scene? Let's do that. I'm gonna drag here from the prefab another instance. Let me place it at 0 and 2, and also another one. So let me place it over here. I'm gonna place that as 0 and -2. Here we go. And let's see what happens if I modify my prefab. Before I do that, also let me rename these objects and place them as children of elevators manager. So I'm gonna drag them here, and I'm gonna rename this one to be elevator 2 and elevator 3. The name of objects does not belong to the prefab itself, so I can rename them without modifying the prefab. So now I'm gonna double click on the prefab. Let's assume I want to take my door R and disable the mesh renderer temporarily, go back, save, and see that the change got applied on all of the prefabs that are referencing that prefab and not overriding the change. What I mean by not overriding the change? Well, I mean that if you go, for example, and take your elevator tree and go into your door right and decide to instance specific enable the mesh render, now you are overriding that specific instance with this value mesh render enable, and so that will not follow the prefab change anymore. You also notice that because here there is a mesh renderer which becomes kind of bold, and that means the change has been overridden on the prefab. So right now, whatever you're gonna do on the prefab itself, so let me modify, double click on the prefab again and modify it, re-enable my door right, go back, save. See that now everything seems like before, but look at this, if I go back here again, re-disable my mesh renderer on the prefab, go back again, see that only the two instances that were still currently referencing the prefab got the change applied as well. But this one here is overriding that change and is not following the prefab anymore. So how can we reset to the previous state? Well, if I select my elevator, I can go into overrides and say revert all. So click on that, and now this instance is referencing the prefab just like before. So this was the preview of prefabs and how they work. We are going to make changes on the prefab only by assigning a new script component to these elevators. Okay, now it's time to move to the coding part. I'm gonna select my scripts folder, and here I have an elevator folder which was originally used on the elevator object we had. Now things changed, so if you go into the elevators manager, this is an empty object to which we will attach our new script elevators manager. In order to do that, I wanna keep some logic from the elevator, so let me rename this elevator to be elevator manager. Okay, this thing here will change, so let me close this and go back to Unity. Remember that when we modify a file name, we also need to have a class name which looks the same as the file name. So here elevator becomes elevator manager. Let's save. I can go back. I can select my elevators manager, drag and drop my elevator manager script onto this object, and now this elevator manager will deal with the logic for all the elevators. But we also want a script specifically on each elevator. So let me create a new script here, which I'm gonna call elevator. Let's open it up. Here we go. So before I do anything here, let me save, go back. And what I'm gonna do, I'm gonna take my prefab, open it up, so I can assign a component to this elevator. And what I'm gonna assign is actually the elevator script that I just created. So let me drag and drop that here, save the prefab, go back. And now you probably notice that all of the elevators, so elevator 1, elevator 2, elevator 3, they all have an elevator script. But also, they still have the elevator manager that changed since before. So let me remove that. I'm gonna remove that on the instance number 1. So right click, remove component. And also I'm gonna remove this cube script, which I'm not using anymore. So right click, remove component. I did that only on instance 1. I wanna do that for all prefab. So I can simply go up here, say overrides, apply all, and now if I select all of the other elevators, you see that all of them are only having the elevator script on it. So let me save this in, and it's now time to go back and write some code. So first of all, let me explain what I'm going to do. If you go back to the elevator manager, which was the elevator script before, this logic now works only partially because this logic was meant to be specifically on each specific elevator. So we have a problem here. We will need to move some of the logic on the elevator script, the logic that belongs to the elevator itself, and we'll keep just the logic of managing all the elevators in this elevator manager script. So what I'm gonna do, I'm gonna move into my elevator script, and I'm gonna get rid of all of these start and update and comments. I don't need them. And I will start writing a couple of public variables. I'm gonna make them public simply because I will need to access them from other scripts. And I'm gonna call the first one to wait time is equal to 3f. And this is gonna be the wait time just like I had in my elevator manager before, but this is now specific to each elevator. And the second variable I wanna have is public bool going up is equal true. All right, so I'm assuming each elevator starts at the ground floor. Then what I'm gonna do, I'm gonna take my wait logic. So let me go into the elevator manager and scroll down, copy that wait. Actually, you can cut that from here. We are not gonna have it here anymore. So cut that, go into the elevator and just paste that here, okay? So the wait logic has been moved to the elevator script itself. We just need to slightly change this code to be, instead of elevator here, we actually get the transform position, because this script will belong to each elevator, so we just need to do transform position here, and not elevator transform here, but as well transform position.x. Going up is fine, and here the same, I'm gonna get rid of this. Now we still have a problem with max height. Max height is a global variable that was on the elevator manager. I can leave it here, but what I can do, I can simply rename that to be public const float max height is equal to 9f. And now I need to get rid of this private float max height because they share the same name and this is not allowed. So let me get rid of that here. I can go back to the elevator script, and here I can access that in a static way. So that means I can simply do elevator manager dot max height. So I will use that max height which stands on the elevator manager script. Now, next step is I want to have a logic that is able to open and close doors once I reach the platform level. So what I can do here, I can write another method. So private void open close doors if wait time is bigger than 1.5f, which means if I'm in the second part of the wait, I will actually close the doors, and below here I can open the doors. We'll deal with this logic later. Let's just comment it out. So here we do close doors and open doors. Now we'll move back to the elevator manager logic. Okay, back to our elevator manager script. What we're gonna do, we're gonna change this script a little bit so that we adapt to the new logic. First of all, we don't have one single elevator public game object here, but what we will have is an array, so a data structure holding all the elevators which are the children of this elevator manager. So what I'm gonna do here, public game object array, this is the way you can define arrays, which are basically collections, okay? And here you do elevators, so I'm gonna change this name. This is the public const float max height we created before. I'm gonna get rid of this string, which I'm not using anymore. And what I'm going to do here, I'm gonna get rid of wait time and going up, which do not belong to this script anymore. And I'm gonna replace that with private integer elevators count is equal 0. Now we need a start method. This start method will be called initially when I press play or I instantiate an object. So this is perfect for collecting all the children elevators, and I can do that simply introducing the concept of loops. Now we have a few ways we can write a loop. We'll see the for each loop at first, then we'll see an example of a while loop, and then we'll also see an example of a for loop when we do the open and close doors. Now let's start from the for each loop. A for each loop is defined like this. So for each something, so an alias, which can be, for example, transform child in transform. That means if I do that, I'm gonna iterate through all the children within this transform, so all the elevators that are children of this elevator manager container. And by doing that, I can access each child. The only problem here, if we do that, we are kind of losing possibility of keeping track of the current index, and we need something like this to actually assign the array element each time we find a new elevator. So here, let me do something like this. Integer index is equal 0. Inside the for each, I'm gonna do elevators at index, which initially is 0, is equal to child dot game object. I need game object because I need to cast this back to a game object, since my array, my collection, is of type game object. Don't forget that we need to do index plus plus to increment the index at each iteration. So once this will be completed, we have a collection of elevators. Also, before here, we are gonna do something like elevators count is equal to transform dot child count. And this returns the number of elevators that we currently have as children. Elevators is equal to new game object of size elevators count. So we're actually initializing the array with the number of elevators we know we have as children. Now something like this can be done also using a while loop. So now I'm gonna comment this out and show you how you can do the same thing using a while loop instead. So let me say integer L count equals 0, and here I do while. Now while takes in a condition, so this loop will run up until the condition is successful. While L count is smaller than elevators count, I'm going to do the same thing as above. So I can simply copy this line, paste that in here. I just need to replace index with L count. And here I don't have a child because I'm not using an alias to access each children, but I can select each child by index in the transform. So I can say transform dot get child at element count dot game object. And don't forget here element count plus plus. Okay, so this will work exactly like the for each above. Now, what about the update? Now, the update needs some change because here we were only updating one single elevator. This will change and I can use the same logic, so a for each, to access each elevator in my collection and simply do the same on each elevator. So let me do that. Here I can do something like for each game object elevator in elevators, so my collection elevators. And I can simply take all of these, cut that from here and bring it inside. And I don't need to make any change on this because now elevator becomes the elevator that I'm accessing. So I'm gonna perform this logic on each elevator. I will need to change something on this string because here I can do something like this, elevator, and print the elevator name. So I can say elevator dot name plus is at floor plus current floor at elevator position to string. So this will not change. Now we have a problem. I'm processing the elevator, but I don't know which elevator I'm processing. So here in the process elevator, what I'm gonna add is a game object elevator parameter, which I will pass here. So here when I call process elevator, I actually pass the elevator I wanna process. And so the only thing that remains is to fix this process elevator logic a little bit. Okay, first of all, I'm going to actually get an elevator component from the elevator object. So elevator EL is equal to elevator dot get component elevator. So I need to do this because I don't want to replicate this call many times. I can do it only once with a local variable. And here I can do something like this, EL dot going up. Now notice that I can do this because going up, just like wait time, is public, okay? So if I go back into my elevator, everything that is public will actually be accessible from outside. Notice that I will need to access wait. So here I'm gonna change this wait to be public. Now for the open and close doors, I don't need that to be public because I will be calling it internally from this class, okay? So let me go back to elevator manager. Here the logic is correct. I only need to change the call on wait specific on each elevator. So el.wait, here it becomes el.going up, here it becomes el.wait, and here I have el.going up. So I can save this, but I'm not yet dealing with the doors. So I need to go back into my elevator logic and deal with open close doors. We learned how to work with the for each and with the while. Now I'm gonna show you another possibility, which is the for loop. Now the for loop is very similar to the for each, but it gives us control on the index itself. To show you the for loop, what I'm gonna do, I'm going to iterate through all the children of each elevator, which are nothing but the doors. And I can do that by doing for integer door index is equal to 0, door index less than 2, door index plus plus. So this is the initial index value, this is the condition up to the for loop will be running, and this is the incremental. Why do I need to index the doors? Because actually the two doors will be moving in the different direction when they open and they close. So I need to know the specific index to control that direction. For example, I can do float dir is equal to door index. If door index is equal 0, direction will be 1f, otherwise it will be negative 1f. And here, to move the doors, I can simply do transform dot get child at door index dot translate, and I can translate towards vector 3 dot forward, which is the opening or closing direction, times time dot delta time, times 0.2f, which is a scalar that brings the motion down a little bit, and multiply by dir, which is my direction. Don't forget to add a comma space dot self so that we make the motion to be local. Now for opening the doors, I'm gonna do something almost identical. So let me copy this, bring it down here, but the only thing that changes is the direction. So if door index is 0, direction is negative 1f, otherwise it's 1f. So I just need to invert those values. And where do I call this method? Well, since my motion is based on the wait time, I can simply call it here. So while I wait, which is here, I can say, okay, open, close doors. Okay, so everything looks good. We can save and go back to Unity. Make sure that the elevators manager has the elevator manager script on it. And you probably notice this elevators collection, which right now is empty, but as soon as we press play, this collection will be filled with all the elevators. Before we actually press play, don't forget we need to re-enable the door on the prefab. So let me go back to the prefab, double click on that, select door R, re-enable the mesh renderer, go back, save, and now we can save the scene and press play. I'm gonna keep the elevators manager selected to see the elevators collection filling up. Here we go. Our elevators are climbing, and at some point they will reach the higher platform level, and the doors will open and close, and then back down again. Here we go. Open and close. And notice that here you have a collection of elevators, which are referencing elevator 1, elevator 2, and elevator 3. And here in the console, you also see the values specific to each elevator. So you see that the 3 values right now are identical, but this logic works also if the elevators start not from the same height. For example, let me pick elevator 2 and bring it at height Y2, and elevator 3 and bring it at height Y4. And if I press play like this, you will see that the logic works exactly like before. And you will see that once each elevator reaches the highest level, it will open and close doors independently. And then they'll go back down and do the same on the ground floor. See? Alright, we can stop. So we learned today how to deal with prefabs, and also we learned about loops. Next time we'll deal a little bit more into details about time and delta time and coroutines, which are 2 crucial concepts in Unity and in game dev in general. And I really thank you for joining today. Don't forget to subscribe to the channel, hit the like button, and also write in a comment if something is not clear or you need some more details. And I'll see you in the next tutorial.